Hey everybody, this is Michael Parent from Michael Parent Consulting Company. Today what I wanted to do is give you a little vignette into one of the productivity tools I've created within Excel. This one is actually for a very high-powered, high-leverage tool that we use in Six Sigma and statistical consulting. It's called the design of experiments. And essentially, a lot of times when we're in complex systems, we want to understand what factors are influencing our output, but we also want to understand something more than just how is factor A influencing it and factor B influencing it, but what if factor A and B work together? Is that having a greater influence on my outputs? We might call that an interaction effect. Is factor A and factor B interacting together to produce something greater than the sum of its parts in terms of my output, be it in supply chain, in medical, in a factory setting as well. So what I have here is I'll just walk you through a little design of experiment that I ran, and then I'll show you how this productivity tool works and what the outputs look like for this tool. Now, what we have here is three different factors, and this is a three-factor DoE design of experiment. Here, what I'm looking at in terms of output is how many linear feet of paint I was able to get, in this case, on a tire striper. So if you've ever gotten a new vehicle, you've seen that tires sometimes have like a paint stripe on it. Well, this was actually a process to get the most out of that paint that they possibly could. And they looked at doing three different factors or expressing three different factors in this design of experiment: the temperature, the viscosity, and the agitation rotations per minute. So they had this little agitator in the paint that was kind of stirring it up. And what you do in a design of experiment is you're not looking at all the possible settings that are possible in each of these things, but you're going to take a low and a high setting. So with a low setting, for the temperature, we're looking at 45 degrees. High setting, we're looking at 90. Viscosity, we're looking at, adding agents into the paint. Low setting at 6, a high setting at 10, and then the rotations per minute, 11 and 16. And I think those are in thousands. But what we see is when we do these sorts of design of experiments and we take the low and we take the high, we kind of see we're not looking for the actual optimum, but we're looking for the effects that are going to be generated by putting something at a very high setting versus a very low setting. Well, they're contrasting enough to really capture any kind of what we might call main effect and interaction from this experiment. So these are our three factors, and what we get from these three factors is this productivity tool actually develops a table for us, and the table tells us how to run an experiment. So I want to run one trial with the temperature at 45 degrees, the viscosity at 6, and the RPMs at 11. And then I ran two trials for that. And then it's going to change one of the settings, 45, 6, and 16. So it changed this one, setting C, the RPMs, from low to high. And essentially what this does is it kind of takes all of these different possibilities and does something which is called a fractional factorial design. So take out a statistical dictionary if you don't know what that is, but essentially we're creating the highest leverage. We're trying to gain the most insights by running the fewest trials is essentially what happens. And what's really nice about this is it tells you exactly which trials to run. All you have to do is put those settings in place and observe, collect the data empirically, and then you'll see what the outputs look like. So everything else is automated and it's generated automatically. And the first thing that we look at when we do some sort of statistics like this is the main effects. What effect is A having, or the temperature having, on the amount of paint or the amount of linear feet I can get out of my paint? What is factor B, the viscosity, having an impact? And what is factor C having an impact? And we can see when we look at this that, yeah, factor A is having a really large impact, factor B not so much. But we also see these other things. When A interacts with B, we're also getting a very large impact, which is alerting us that there is actually something called an interaction effect going on here, which is saying, yeah, it's actually way more optimal to have A and B on here. So it's not always additive. You can't say, well, I'll take A and B and C, but you can certainly say that, yeah, putting A and B together is going to yield us a greater possibility than having just A alone or just B alone, which is really a fantastic insight into your operation, because you're understanding not just what factors are affecting my outputs, but how are these factors affecting other factors affecting my outputs. So it's getting kind of meta, so to speak. And what we have here, we can also plot out these interaction effects on what we call interaction plots. So pretty much anytime we have an interaction, we will see we will see one of these series cross over the other series. And in this case, if we look at A versus C, we see that there's not an interaction. A always remains high, and C always remains low, right? So no matter what setting I use, I've got 4 different settings here. I've got A low, I've got A high, I've got C low, I've got C high. There's no interaction. One does not cross over the other. And I can look at that for B as well. But if I go to AB, what I see is that, look, A was actually lower than setting B, but once I started taking these together, and A and B was high and A was high, what we see is that, yep, in fact, I have that interaction, and that now I'm performing at a level that I wasn't performing at without both of these factors being implemented into the process. So it's certainly a high-level thing. It's certainly an elegant statistical tool. But all I want to show you really is, one, that this is totally capable within Excel. A lot of statistical packages cost a lot of money. The licenses is a lot. And really, this is not something that you need a huge statistical package for. You simply just need to have a good knowledge of statistics, maybe a statistics textbook, to build this sort of thing. And I think it's indicative to show how you can really stretch Excel to that 98th, 99th percentile to get the most out of the tools you already have and make your process a whole lot better, be it through operations or for doing some kind of design of experiments, gaining greater insights into your operations through this kind of hard-nosed analysis. So if you have any questions about design of experiments, Six Sigma, or extending the usability of Excel right within your desktop application, please message me, let me know.